Okay, and I'm going to share my screen. Okay, can you see my screen?
No. Okay, yeah, I see it now.
Okay, so yeah, okay. So this is the topic, one of the topics basically. And to save time, I have already just, noted down everything just so I don't have to write it down. Okay, so let's talk about real numbers. All numbers on the SAT are real numbers. Real numbers include the following sets. Okay, so real number is a big topic with different branches. Whole numbers, integers, rational numbers, irrational numbers, all of these are real numbers. Okay, and this is a very, very important topic. Okay. Right, so what are whole numbers? Whole numbers are known as counting numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is what whole numbers are. Whole number is any number which is positive and there's no decimal in that number and it's not a fraction. Okay, any number of this sort like 10, 11, 12, 1. So all these numbers are positive. There's no decimal in this number. There's no fraction in this number. So these numbers are whole numbers. Okay. Let's talk about integers now. Integers are positive and negative whole numbers. And the number 0 as well is an integer. So if I add a negative sign to these whole numbers, they would not be considered as a whole number, but they would be considered as an integer. And remember, 0 is a whole number as well as an integer as well. Okay, these numbers are very important. So real numbers is a big topic. We have different branches. Whole numbers, number one, we are done with whole numbers. Integers, any whole number which is either positive or negative is an integer, and 0 is also included. So basically these numbers are also integers as well. This 11, this 12, this 10, they are positive integers, right? But when it comes to negative integers, we are just going to consider them as an integer. They are not whole numbers. Okay, am I making it clear?
Yes, ma'am.
Perfect. Okay, so next is rational numbers and irrational numbers. Now this is something which gets a bit confusing at times, but I'll try my best to clear up this. Rational numbers are all numbers that can be written as fractions, terminating decimals, and repeating decimals. Rational numbers include integers, okay, because if I have this integer 2, I can write it down like this. I can still include a decimal, or if not a decimal, then I can always write it down as a fraction. So whenever you have an integer, just remember this, that integers are always rational numbers because they can also be written with a decimal and with a fraction, right? So look at this 2. This 2 by 1 is basically 2. 2 by 1 is 2. And 2 is an integer. But since we can write it like 2 by 1, so it is also a rational number. So what is the rule? The rule says if a number can be written as a fraction, terminating decimal, repeating decimal, then it is a rational number. Now, what do they mean by terminating decimal? Okay, this is an example. Okay, if we have a fraction, let's say I'll just quickly write down a fraction. Let's say we have, okay, let's say we have 7 divided by 8. Then we have 1 divided by 3, and then we have a fraction, let's say x by y, and the answer is this one, 0.5. 3, 8, 6, 5, 8, and it's going on continuously. Okay, it's not stopping. So the answer in this case is 0.875. The answer in this case is 0.333, and it's going on. So, and this is going on continuously. Okay, it's not stopping. So this is basically an example of terminating decimal. After 3 decimal places, the number has stopped. So this can certainly be considered as a rational number. 0.875 is a rational number. Why? Because the decimals are fixed. We just have 3 decimal places. We are not going on continuously. Okay, the number has stopped after 5, after 3 decimal places. If I talk about this 1/3, it's not stopping. When we solve it using a calculator, it looks like it stops after 10 to 12 decimal places, but it's not the case. It's just because the calculator has a limit of showing certain digits. That is why it stops. In case of 1/3, we would have 0.33333, and this would go on continuously. But this again, the decimal in this case is not terminating. In this case, the decimal is not terminating, but since it is repeating, and whenever a decimal place is repeating, we can write it down as 0.333, and like this thing means that the decimal is repeated. So this is also a rational number. But when I talk about this number, in this case, the number stopped after 8, but here I said that the number would be going on continuously, and we would be having different digits after every decimal place. The trend would not be repeating, as in it is not going to be something of this sort, 0.38656565. No, in this case the situation is different. In this case the situation is different. Okay, I'll explain you properly. Okay. Right. So let's say 0.3658971, and it's going on continuously. It's not stopping. But on the other hand, if we have a number of this sort, this is also going on continuously. It's also not stopping. But this is a rational number because the decimals are repeating. We have repeating decimals. By repeating decimals, we mean that after a certain number of decimal places, the numbers have started repeating. So I can write it down as 0.365, like this, okay? But in this case, the numbers are different and it's going on continuously. So this is not a rational number because neither it is terminating decimal nor it is repeating decimal. So this is an irrational number. Okay, is it clear now? Okay. Now I have a question for you. Why are they saying that pi is an irrational number? Although we know that we can always write down pi as 22/7. So why is it an irrational number? I mean, the rational numbers definition just said that if something can be written as a fraction, it is a rational number. But the answer is, although pi is 22/7, we can write down this fraction in this way. But when we solve it, the answer or the decimal places would be like this. The decimal places are neither repeating. This 242424 is not repeating. The numbers over here would be different, and it is not terminating. So a number with with infinite many decimal places and the decimal places are different would be an irrational number. No matter if we can write it down as a fraction or not, we always need to make sure that, okay, if something can be written as a fraction, what is the answer? This 1/3 was also a fraction, but we had to make sure that, okay, when we solve this 1/3, the answer would be a repeating decimal. So it's not just this, that if we can write something in decimal in a fraction, then it would mean that it is an rational number. Okay, is it clear?
Yes, ma'am.
Perfect. Okay, so we'll be discussing practice questions as well, but first I'll cover up all the topics and then I have prepared the appropriate practice questions for these topics as well. And please ask me whenever you want to, because this is a one-on-one session. So, I'm here for you. You have to ask me continuously, okay? And I would love that. Because I personally, mathematics has always been more than a subject to me. I love maths. And I would honestly appreciate if you ask me. Okay, so let's just move on to the second topic. I've already prepared the topic like this to save time. Okay, and these topics, I've prepared these topics from the SAT book. Okay, so these are the SAT topics. Don't worry about that. Right, okay. So, comparison symbols. Okay, this is something very simple. I'll just take 3 minutes. This is equal to, this is not equal to, this is greater than, this is greater than equal to, this is less than, and this is less than equal to, right? Okay. So 3 equals 3, we know that. Since 3 and 3 are equal, we have used this sign. 6 and 7, 7 and 6, they are not equal to each other, so we have this not equal to sign. 5 is greater than 4, so we have written the greater number on this side and the smaller number on this side. Okay, 5 is greater than 4, right? Okay, x is greater than equal to 2. Now x can be 2 or any number that is greater than 2. Why? Because this sign says greater than equal to. X is either 2 or it could be 3, 4, 5, 6, 7, 8, any number which is 2 or greater than 2. Simple. This is less than, 1 is less than 2. Very simple. 1 is smaller number, 2 is a greater number. We have this less than sign. And now we have this less than or equal to. X is less than equal to 8. X can be 8 or any number that is less than 8. So x is either 8 or it is 6, or it could be 7, it could be 8, it could be 5, but it can never be greater than 8, okay? It looks very simple, but in SAT, when you'll be solving the word problem statements, although there would be MCQs, but still the questions would be of this sort that, let's say we have a number x that is greater than equal, well, let's say if they're talking about age or something of that sort. So if they say that there are two brothers, one is Ali, other is Ahmed, and Ahmed's age is either greater than or equal to Ahmed's age. So in those questions, you have to be very, very careful that either you will be using this equal to for making the equation, okay? So it is either going to be an equality or an inequality. Either you will be using this equal to or greater than or less than, greater than equal to, less than equal to. These inequalities and these signs are very important for equation making. It looks very simple over here, but when you have to convert a word problem statement into an equation, you have to be very careful with these words, okay? Equal to is simply equal, not equal to is this, greater than is this, and greater than equal to is this. Less than is this, and less than equal to is this. Okay, is it clear now?
Yes, ma'am.
Okay. Right. We'll take a break at 11. I need to call Zahib and ask his status as well. Okay. Yeah. So we are on the third topic now. The SAT topics are really, really easy. Honestly, they're very easy topics, but we need to practice questions. So I have also planned practice questions for this session. It's all about practicing SAT past papers in time. That's it. Okay. And some concepts look like they're very basic, and I honestly used to skip such topics. But then when I was practicing past papers, I was lucky enough that I got this idea that okay, the topics are easy, but I should still look into the topics. So then I had time, so I was able to do well. Otherwise, I also skipped topics and just started doing past papers. That is not a good idea. Okay. All right, so symbols of multiplication. A factor is a number that is multiplied. A product is the result of multiplication. Okay, very easy. So this is an example. 7 and 8 are factors. And this 56 is the product. But Ishan, my question is that 7 and 8 are factors of which number? Which number? I mean, which number are they talking about in this case?
56.
Excellent. Okay. So 56 is the product, 7 and 8 are the factors. You can represent multiplication in the following ways. Okay. So a multiplication sign or a dot between factors indicates multiplication. Very easy. This is what we have been doing. This is something which I'm pretty sure you would be already knowing, right? So if we have um, a dot between two numbers, okay, it could be a decimal, but decimals are represented in this way. So if you have it like this, you should know that this is a product, right? It's not a decimal. You need to be very clear with this, right? So this is 48. Okay. Parenthesis around a factor indicates multiplication as well. If we have two numbers written in this way, 7 bracket 8, this means that these two numbers are being multiplied to each other. Multiplication is also indicated when a number is placed next to a variable. Very easy. 7a, if we have 7a, we know that it is already the product of 7 and 8, right? This is something which I'm sure you already know, right? Is it clear? Should I move on?
Yes, ma'am.
Okay, right. We'll cover 7 topics and then we'll solve the practice questions. Need to see, yeah. Okay, right. Like terms. A variable is a letter that represents an unknown number. Variables are used in equations, formulas, and mathematical rules. What a variable could be A, it could be X, it could be any alphabet which we are using instead of a number when we are trying to find the number. And variables are used in equations when we, make equations from a word problem. Maybe 7a equals 70, something of this sort. So it can be used in equations or it is used in formulas. Let's say if we talk about the formula of area of a square, we have length into breadth. So obviously, when we are saying length into breadth, this varies in every case. This is why these are variables, okay? Because these are numbers which can vary from situation to situation. Okay. A number placed, yes.
Can you zoom in a little? I can't really read what's written.
Okay, sure I can. Hmm.
I think the plus sign you see at the
Yeah,
left.
yeah.
Okay.
Okay. Is it readable now?
Yeah, that's fine.
Okay. Right. So, like terms, a variable is a letter that represents an unknown number. Variables are used in equations, formulas, and mathematical rules. I think this line is clear. A number placed next to a variable is the coefficient of the variable. Okay. So, if we have this 9D, 9 is the coefficient and D is the variable. Okay. This is what the statement said. Whenever we have a number, let's say we have 10, we have x. This 10 is the coefficient of this x. If we talk about this 12xy, 12 is the coefficient of both the variables x and y. And in this case, x and y are being multiplied to each other. Okay, this is very obvious. Is it clear? Is it clear? I can't hear you. Yeah, is it clear?
Yeah, I say yes.
Okay. If two or more terms contain exactly the same variables, they are considered like terms. Very easy. If we have 4x, 7x, 24x, 156x, all of these numbers have this x in common. When the variable is same, these terms are considered to be like terms. And it's very important for us to know what like terms are and what unlike terms are, because only then we'll be able to simplify expressions and equations. Again, here A and B are same. A and B are common everywhere. So this means all these terms are like terms. We can add or subtract these terms, okay? Variables with different exponents are not like terms. I'll explain what they mean by this. For example, 5x cube and 2xy cube are not like terms. Like now, like although we have 5xy and 2xy, but there's a difference. We have cube on x, and in this case, we have cube on y. So, both although x and y are same, but it has not only to do with x and y, but we also need to see the power, right? This is what it says. Variables with different exponents are not like terms. Here the exponents are different. We have x cube and we have y cube. So these two are not same. So these two numbers are not like terms. Okay, they are not like numbers. We cannot add or subtract them. In the first term, the x is cubed, and in the second one, y is cubed. So these are not like terms. Okay, you can combine like terms by grouping like terms together using mathematical operations. Very easy. 3 and 9x, 3x and 9x, these two are like terms. We can add them. The answer is 12x. 17a minus 6a, these two are again like terms, but we have to subtract them because this is the mathematical operation. So the answer is 11a, right? So this is what like and unlike terms are, but be careful when you are solving questions and you have less time. This is something which we know, which we obviously know, that x cube y and xy cube are different. But when we are but when we have less time, we just um, end up adding or subtracting these terms, or we end up considering these two as like terms. So never ever do that. Is it clear?
Yes, ma'am.
Okay. We are on the fifth topic. Hmm. Ishan, you are doing A levels, right?
Ma'am.
Okay, so the basically the metric in FSC, this is something which we are used to. But honestly, when I was doing A levels, I did not specifically know that okay, this thing I know existed, but I never knew that this is associative property. And if we see in metric students, the system and the management and their education program, whatever you call it, they make them learn these. Okay, so these are very important from SAT point of view as well. So you have to learn these properties. Okay, okay, and they're very easy. Don't worry, I'm with you. Let's talk about the commutative property of addition. When using addition, the order of the addends does not affect the sum, obviously. By order, they mean either you can write down A plus B or you can write down B plus A. Okay, this is same. You don't have to learn these English statements, obviously. All you need to know is that if they're saying A plus B equals B plus A, it means it is commutative property of addition, right? So we know this, right? 7 plus 3 is equal to 3 plus 7. This is something which we already know. Let's talk about the commutative property of multiplication. So when they are saying commutative, just remember they're just swapping the numbers. They're just, if we have A and B like this, B would be the first number and then A would be the second number. This is what commutative means. Either it is addition or it is multiplication. When it is addition, it would be A into B equals B into A. We already know that 4 into 6 is 24. And if I write 6 into 4, that is also 24. So the order of these numbers, which can either be addends or be factors, does not matter in case of multiplication and addition. But yes, if I talk about division, and yes, if I talk about subtraction, this would matter. As in, A minus B is not equal to B minus A. Definitely, because let's say I have 10 minus 2 and I have 2 minus 10. The answer here would be 8 and the answer here would be minus 8. So they are not equal. Similarly, 10 divided by 2 is not equal to 2 divided by 10. So these two laws only hold for addition and multiplication. Okay, just remember this. Commutative means simply swapping two numbers and ordering them again. Okay, 7 plus 3 equals 3 plus 7. 6 into 4 is equal to 4 into 6 because multiplication and addition, they hold the commutative property. Right, is it clear? I can't hear you. Please confirm if it's clear or not.
Can you hear me now?
Yes, I can hear you now. I can hear you, but what did you say after that? I could not hear that.
It's clear.
It's clear. Okay, I'm really sorry, but I can't, I'm not able to hear you properly. Okay, let's talk about the associative property of addition. When adding three or more addends, the grouping of the addends does not affect the sum. A plus B plus C is basically A plus B plus C. Okay. Associative property in cases of addition and multiplication have a similar structure. So it says A plus B plus C is basically A plus B plus C. And what is the significance of these brackets? I mean, what am I trying to, say basically? Why are these brackets important? Can you tell me?
The brackets show which two numbers were added first.
Excellent. So we can either add these two and then add A, or we can add these two and then add C. The answer would be same. Why? Because this is the associative property of addition. Associative property of multiplication. When multiplying three or more factors, the grouping of factors does not affect the product. Okay, we have this example. 5AB is equal to 5AB because we can either multiply A and B first and then multiply it with 5, or we can multiply 5A and then multiplied with b. The answer would be same. Why? Because this is the associative property of multiplication. Okay, right. Let's talk about the distributive property. When multiplying a sum, when multiplying a sum or a difference by a third number, okay? This is a sum and this is the third number. A and B are two numbers, 7 is the third number. So the statement says when multiplying a sum, this is a sum, or a difference, this is a difference with third number, which is this 9 in this case, and in this case it's 7, by a third number, you can multiply each of the first two numbers by the third number and then add or subtract the products. Okay. You can multiply each of the first two numbers, right? You can multiply each of the first two numbers. So in this case, we have 7, A plus B. We are going to do it this way. 7A, we have to multiply these two numbers with this third number first, 7A plus 7B, and then this operator would come in between. If I talk about this example, 9A minus B, 9A, 9B. Simply, we have first multiplied these first two numbers with the third number. This is the third number in this case. And we have simply written down the operator in between. Don't get confused with these statements. All you need to know is when it is commutative, simply it's about the order. And then when it's about the order, it means you have two numbers A and B. So A plus B equals B plus A, and A into B is B minus B. A into B is B into A. Okay, this is what the commutative property is. Commutative has only to do with the order. Associative. When it comes to associative, we have to deal with the brackets and order as well. So we have brackets in this property, and the rule says that either you can add these two first and then add this, or you can add these two first and then add this one. The answer would be same. And the associative property of multiplication is similar. 5AB, you can either multiply this AB first and then multiply the answer with 5, or you can multiply this 5 with A and then multiply it with B. The answer would be same. Okay.
Yes, ma'am.
Okay. And the distributive property is something which we already know. We've been doing this, but just for the sake of completeness, we should know that whenever we have a number that is being multiplied to a sum or a difference, and when we simply multiply this third number with this number and then 7 with b, and we write down the sign in between, this operation is basically the distributive property. This is what you should know. Okay, we have been doing this, but this is the distributive property. We are able to do this because of the distributive property, right? We are done with this one as well. Okay. Okay. Another important thing, order of operations. You must follow a specific order when calculating multiple operations. Parenthesis, first perform. Are you familiar with this PEMDAS or BODMAS? What are you used to?
mass.
BODMAS. Okay, so let's talk about BODMAS then. Brackets, order, division, multiplication, addition, and subtraction. This is something which I would say, which you have been doing since grade 6 or 5th, but still we end up making mistakes. On Facebook, there are random questions where they have given you an expression, and people start writing down the answers in the comment section, and every answer is different just because of the fact that we are not able to use this word mass correctly. Okay, now we have this 8 plus 4 into 3 plus 1 whole square. The rule says we need to use the brackets. We need to solve the brackets first. Okay. So this 8 would come as it is, this plus would come as it is, this 4 would come as it is, this multiply. And we need to solve this. 3 plus 1 is 4 square. So now I can simply just remove the brackets. I can write down 4 square. Now the second is order. So 8 plus 4 into 4 square is 16. Now division, we don't have any division symbol in this question. We have multiplication. So 8 plus 4 into 16 is 64. And then we have addition. So the answer is 72. Okay. Is it clear? Okay. Let me just take out a little bit difficult question, because these questions look very simple, but they are not that simple actually. Yeah, okay. I mean, this example is also very simple, don't take me wrong, but practice is very important in case of these questions, okay? So if I have minus 25 into minus 4 divided by minus 12 plus 32. Again, we'll simply solve the brackets first. This would be minus 25 into minus 4. This bracket was just, this bracket was just because of this minus sign, okay? The divide would come as it is. We need to solve this bracket first. 20. Next step would be, can you tell me the next step?
Uh,
We are going to multiply 25 and minus 4.
That's what seems right, but according to the BODMAS rule,
Mhm.
I think we have to divide.
Excellent. We'll be dividing minus 4 by 20. Minus 25 into minus 4 divided by 20. We simply have to cut things over here. This is 4. This is 5. Minus and minus would be plus, and 4 and 4 would be cancelled. Just a second. Yeah. So the answer is 5. Okay. Is it clear?
Yes, ma'am.
Okay.
Ma'am,
Yeah, yes.
is this how short each topic is? Like that's it for each topic?
Yes, yes, yes. I mean, yes, these topics are very simple, but when we'll go on geometry in that section, the topics would still be simple, but yes, they would need more explanation. So these topics are something which we have been studying, since grade 6 and 7. That is why they look simple. And yes, the SAT topics are very simple, but they need practice. And when we just see that, okay, the topics are very simple, I honestly did this, I just told you. But then when I started doing the past paper questions, I had to revise these topics, okay? I need to see this. Yeah, you've done this one, sorry. Okay, so is it clear? And I'm following a book. So this way we'll be covering each and every question as well as the practice questions. I have practice questions for these topics. And this is the last topic we'll be doing practice questions for this class, as in the first class. And I'll see about the second class. I need to ask Sahib because if we take the second class as well, he's going to miss a lot. So he said that he might attend the classes today, but I don't know where is he. So I'll ask him and then I'll let you know. Okay. So powers and roots, exponents. Okay. An exponent tells you how many times a number, the base, is a factor in the product. Okay. 243 is the product. 33333, all these are factors. And again, this 3 is a base as well. Okay. So an exponent, this exponent is 5 in this case, tells you how many times a number that is base, number that is 3, that is base, is a factor in the product, that how many times it is being multiplied to get this number. So one way of writing 243 is that you multiply this 3 5 times, or you write 3 to the 5, because 3 to the 5 basically means 3 into 3 into 3 into 3 into 3 into 3, okay? So 5 is the exponent. Let's say I have a to the 4. This would mean a into a into a into a, right? This is what exponent means. So a is the base and 4 is the exponent. Exponents can also be used with variables, just like this example. You can substitute for the variables when values are provided. Okay, bn, b to the n. The b represents a number, let's say 2, that will be a factor to itself n times. Okay, b to the n means that b is a number which is being multiplied n times, and obviously at the moment we don't know that what n times is. All we know is that it is, they are n numbers. Okay, these b's are n. So if I'm saying this is 4 cube, 4 into 4 into 4 is 64. This n in this case is 3 and b is 4. Okay. So this is a very simple topic. All you need to know is that when you have x to the y, let's say, this y is the exponent, this x is the number, or it is the base, or it is the factor in case of a product. Okay, is it clear?
Yes, ma'am.
Perfect. Okay, let's move on to the practice questions now. Wait, let me just. Let's just do these three first and then we'll talk about these later. So I'll make that bit more, even more better. Okay. All right. First question. The number minus 16 belongs in which of the following sets of numbers? Is minus 16 a rational number only? Okay, so minus 16 is it a rational number? Is minus 16 a rational number? This is one. Please answer me.
Uh,
Sorry?
it's not.
No, it is a rational number. Wait a second. It's okay. Okay, so I told you when we were discussing rational numbers, any number which can be written as a fraction, terminating decimals or repeating decimals, it is a rational number. And then we said that every integer is a rational number as well, okay? The answer is not A, obviously, but you should know that minus 16 is a rational number, okay?
Okay.
It is a rational number, but this only is making it a bad choice because it is not only a rational number, it is also an integer. Okay, right. So it is a whole number and integer. Minus 16, is minus 16 a whole number?
No.
Excellent. Because of this minus sign, right? So B is not the answer. So whole number, integer, and rational number. Okay, it is a rational number. It is an integer, but it is not a whole number. So we'll be crossing out this as well. Minus 16, integer and rational number. And integer only. Now you would have selected this because you said that minus 16 is not a rational number. But let me tell you, it is a rational number. Every integer is a rational number. Just remember that, okay? Every, when we are solving, I don't know about you if you have solved any past paper exam, but such question, I'm not, saying anything to you. This is what used to happen with me as well. I used to consider such questions very easy, and I used to, in my first past paper, my scores were really low just because of these things. I mean, even I wouldn't have said that minus 16 is a rational number if I was at your age because we know things, but we don't learn them in detail. SAT is very easy, but you need to know these concepts as well. Okay, so the answer in this case is integers and rational numbers, right? Every integer is a rational number. I would suggest you to. I can share the book as well, which I'm using, but I would suggest because books. There are many books of SAT exam. You don't have to look at every detail, but these points, such points, they're very important. So you can note them down in your diary.
Yes, ma'am, I made notes.
Excellent. Okay, this is the second practice question. Okay, so the question. Just give me a second. I can use the eraser, but for some reason, whenever I use the eraser, I'm not able to write it down. So I'll fix this as well for the next class. Okay. So the question says, if A is greater than 37, which of the following is possible value of A? Now this is very simple. A is a number that is greater than 37. So can A be minus 43?
No.
Very good. Can A be minus 37?
No.
It cannot be 35. It cannot be 37 because the symbol is simple. A is greater than 37. It is not A is greater than equal to 37. So the answer is 41 in this case. Okay. Right. If n is 8 minus 5, what is the value of 6n? So 6 into 8 minus 5. So we can either use the BODMAS rule where we solve the brackets first, or we can use the distributive law. I want you to tell me how would I do it using the distributive law?
You would multiply 6 with 8 first, and then 6
Excellent.
with 5.
6 into 8, and then 6 into 5, and then minus sign. This is 48 minus 30. The answer is 18. Obviously, in case of SAT, they would never tell you to do a question using distributive law or something of that sort, but this question will tell you why I asked you to do so. This question. Okay. Let's talk about this one now. 4x squared plus 5y plus 7xy plus 8x plus 9xy plus 6y plus 3xy squared. Okay, so we have a long expression and we need to simplify it. For simplifying, first we have to see which terms are like terms. Okay, this 5y and 6y are like terms. So let's just write down their answer first. So 5y plus 6y would be 11y. Now this has 11y, this has 11y, this has 11y, this has 11y. Only this option does not include 11y. So we are simply going to cross it. Okay. Let's move on to this part now. 7xy plus 9xy. The answer is 16xy. Let's see. Okay, so we have 16xy here, here, and here. We'll simply cross out this. Okay. So we are done with this and this. All right. Next, we'll be having 8x as it is. 8x, we have 8x in all these examples. 4x squared would come as it is, and 3x squared, y, this would come as it is. So this is the answer, okay? This crossing was very important. This was important because we are going to save lots of time in this case. Okay, is it clear?
Yes, ma'am.
Very good, okay. Okay, which equation illustrates the commutative property of multiplication? So what was the commutative property? I told you commutative, always remember it by order. This was the commutative property, right? And multiplication, so we have this multiplication sign. Okay, so is it the commutative property? The first one. And if it's not the commutative property, then what property is it? We have a number, we have a third number which is being multiplied.
A.
So A, what? Oh, sorry, what is A?
A is not the answer.
A is not the answer, right?
Yes, it's not.
Okay, excellent. So A is not the answer.
E
Let's,
is the answer.
which, I'm sorry, I'm not being able to hear you.
E.
E is the answer. Okay, let's see. Let's see. So this is a second option where we have two numbers. This is the first number, and this is the second number, and then this number is coming here, and this number is coming here. So which property is it? This is the commutative property, okay? This is the answer. I'll tell you why. Look, 4.5 into 0.32, this is something which has been written in brackets. So we are going to consider it as a first number, okay? This is A in this case. And this is the second number, this is B in this case. Now this is A and this is B. And we have A into B equals B into A. So this is the commutative property. This is not, this is the associative property. Okay, this is the associative property. It is not the commutative property. In case of associative property, we had this, that we can either multiply this first and then multiply it with 5, or we can multiply these two numbers first and then we can multiply it with this. Is it clear?
Yes, ma'am.
Okay, and what about this one? Again, we have one number and then this is another number, but then this is a third number, okay? Just be very clear with this. Here the brackets were same. The brackets were same. And this is not the distributive property. It looks like distributive property, but the sign is of multiplication. So this is the commutative property. They have represented it in a different way, but this is the commutative property. Are you sure that it is clear? If not, I can explain it to you again.
Yeah, no, I got it. I was confused between the commutative and
Yeah,
associative
okay,
property.
that is not an issue. Right. Let's practice some more questions. Okay. So this is the practice question. 3 into, okay, this is a long, long expression and you have to simplify it. Can you please do it for me? I can give you 3 minutes. Can you just tell me the answer in this case?
Sure, ma'am.
Excellent. You can take your time.
Ma'am, the answer is B.
Excellent. Very well done. The answer is B. Okay. Let's talk about this question. Which of the following is equivalent to 7 to the power 8? My question is this, that what is 7 and what is 8? What are the terms which we have just learned for these two? Is 7 the exponent or is it the base?
7 is the base.
Excellent. 7 is the base and 8 is the power, which is also the exponent. Okay. So 7 would be multiplied 8 times. We simply have to cross out this example, this answer, and this answer because it has nothing to do with 8. 1, 2, 3, 4, 5, 6. No, not this one. 7 and 8. This would be the option, okay? Because obviously, if these are 6, these would be 7, and this is going to be 8. So you need to save time. Don't waste time on counting these 1, 2, 3, 4, 5, 6, 7, 8, right? When once we know that these are 6, these would be 7, so this would be 8. Okay. Now, this is a very interesting question. Which of the following is equivalent to 6 into 12? Okay, we have missed this topic. I'll explain after this, but this is something I think you can do, right? 6 to the 12. Okay. So when we have this, in this case, when we have 6 to the 6, the power is being multiplied. So it would be 6 into 36. In this case, these numbers are added. So I can never ever write down 6 to the power 2 plus 5 plus 5. Okay, this is not going to be the case in this one, right? This would simply be an answer. It has nothing to do with being a factor of 6 or something of that. So this would just be a number. It is not going to be something of this form 6 to the a. Okay, this would just be a number. If I simplify it, I can never ever get a form of this sort. Why? Because these are being added. Now in this case, 6 to the 3 into 6 square into 6 7, bases are same. 6 6 6 bases are same, powers would be added. I have to explain this topic. 6 plus 2 plus 7. Here the answer is 6 to the 12. So this would be an option. Okay, let's leave this question. I have to explain it. I have to explain the topic. I'll explain it.
No,
And
ma'am, I know that.
you know this. Okay, perfect. So this is how you have to do the past practice questions. Okay, right. So now we have 10 minutes break. I'll see you at 11:20. Okay, I need to call Zahib as well. I have to ask if he would be attending the second class or not. Okay,
Okay, ma'am.
perfect. Take care. So you can leave the session and then join again. I would not end the meeting.
Uh, all right. Okay.